Okay, I hope all of you have download this. Please download this file from UKM Folio. Okay. Okay. Today I will focus. I will discuss about section 1.1 concept and definition about the function. Okay, I will start with the domain and range. Domain and range. What is domain and what is range? Please refer to my lecture note. I will use the whiteboard to explain this part. Okay. The first. Okay. Please refer to page 1. Page 1 of my page 1 section 1.1. Okay. I will start with what is domain and range. Okay, what is domain? What is range? Domain and range. Domain and julat. Range in bahasa Melayu julat. Okay. For example, let's say we have this question. Let's say just for example, I have this function y equal to 3x minus 1. Y equal to 3x minus 1. Okay, there is a linear function. For any function, there must be one input and one output. One input and one output. Okay, our focus here is y and x. What is y and what is x? Okay, for this example, when we write y equal to 3x minus 1, okay, y can be defined as output. X is input. What does it mean by input and output? We need input. In general, we can say that we need input to produce output. That's the basic concept between input and output in an economic process, in a firm, in a firm or company, or in a market. In order to produce to sell something, firm need to buy input. To buy input such as raw material, labor, and so on. So in this case, in terms of function, y equal to 3x minus 1, the variable y is called, is input, the variable x is output. We need x. In other words, in this context, we need x. What is x? We must find the value of x. We must select the value of x. What is x? If x equal 1, y equal what? What happened to y? So the number of x must be determined first in order to find the value of y. So in the case, we know that the value of y is depend on the value of x. Right? That's why we call x is input, y is output. And then the set value of input. Set value of input. X can take any value from negative infinity to positive infinity. The set value of input. Maybe we have more than one value of x. X equal 1, x equal 2, 3, 4, and so on. Set value of input. Because the set value of input is called a domain. Set value of input is called a domain. Okay, that's for domain. So domain is referred to input. Input refer to x. Whereas the set value of output is called a range. So now there are two terms here, domain and range. Domain is related to x, to input. Range is related to output, or y, the value of y. Okay, for example, please look to example 1.1. Please refer to example 1.1. Let's say I have this question, y equal to 3x minus 1 again. And then we have a domain, the set of input or domain. The value of the domain is 2, 4, and 6. There are three values for x, x equal 2, x equal 4, and x equal 6. So we need to find a set of range. What is range? Let's see, range is a set value of y. Maybe y1, y2, y3. What is the value of y when x equal 2, or when x equal 4, or when x equal 6? The basic concept, the relationship between domain and range. Okay, how to find the range? Subject to the value of x 2, 4, and 6. Okay, basically we can say that in order to find y, we need to what is y? What is x? We need value of x. Now, so if x equal 2, y equal what? What is y? When x equal 4, what happened to y? And then when x equals 6, what happened to y? So I can write here, there are three values of x, 2, 4, and 6. And the y, the value of the function, the value of y is equal to 3x minus 1. So we just replace x equal to, when x equal to, what is y? Y equal 3 times 2 minus 1. 3 times 2, 6. 6 minus 1 is 5. Okay, that's why the value of y when x equal 2. When x equal 4, the same process here, the same thing. We just replace x equal 4. 3 times 4, 12 minus 1 equal 11. And then when x equal 6, y equal 3 times 6, 18 minus 1 equal to 17. Now we have one value of y. 5, 11. That's 11, and 5, 11, and 17. That is the set value of y, range, the value of the output. So I can replace here the range, the set value of output is 5, 11, and 17. Okay, that is the range. We set the set of range for y, the y value of y. Okay, that the basic concept of domain and range. In other words, we can say when in any function, there must be a y and x. There must be a domain and range. There must be a what we call it input and output. Okay, that's the theoretical part of function. We will apply this concept of function in this course, especially in topic 1. Okay, the second one, if you refer to example 1.2. Example 1.2. Okay, this example is for application. In the class, for this topic, there are two parts. The first part, for each topic, the first part is about the theory. The second part is about the application, how to apply the mathematics in economy and business. Okay, let's say look example 1.2. Suppose the revenue function of a firm is TR equal to 100Q minus Q squared, where TR is a total revenue and Q is a total sale. specify the range of revenue function if the maximum limit of sale per month is only 50 units. This question is related to the application of function. Okay, for this application, we want to apply the total revenue, total revenue function. Okay, again, given in the question is the total revenue function, TR equal to 100 Q minus Q squared. 100 Q minus Q squared. Now we have TR and Q. No more Y and X. But we can apply the input and output, the concept of input and output, the concept of domain and range in this question. This total revenue question. What is TR? TR is total revenue. Q is quantity. Q is a quantity of sale. Oh, Q is quantity. Normally in economy, Q represent quantity. Is TR. Total revenue. Okay. What is total revenue? Let's see. What is total revenue for a firm? I will explain. I think you learn about this theory from PPS, perfect competition model, monopoly, oligopoly, and total cost, total revenue in the microeconomic class. And then we will apply that concept, total revenue, total cost, and so on. We will apply the concept of mathematics and I will show you how to apply the mathematical concept, mathematical theory in total revenue, total cost, or any other economic function. We know that the total revenue is cash earned by a firm. When a firm sells something, there is a price for that good. The price of a good times the quantity sale, that's equal to total revenue. The amount of money earned by a firm. There's a total revenue. The best. I will explain more later. So for this example, we have a total revenue. We have a function. Total revenue is equal to 100 Q minus Q squared. Now, in this function, TR equal to 100 Q minus Q squared. The value of TR is subject to Q. The amount of total revenue is depend on the quantity of the number of Q, the number of quantity sale. If you assume the P is fixed, the price is fixed, the higher if the Q is the higher the Q, the higher the TR, because P times Q equal TR. If quantities of sale increase, if quantity of sale Q increase, the total revenue also increase. Normally there's positive relationship between P and Q. Okay, so in this case, in terms of input and output, we know that TR is output. The value of TR is subject to the value of Q. But that's how we can relate. Based on the theory, we know that input will determine total revenue, or total revenue. The number of total the amount of total revenue is depend on the number of quantity sale by the firm. So we can conclude here that Q is input, TR is output. So the set value of Q, the set number of Q is also equal to domain. The set value of output of TR is also equal to range. That's how we relate the mathematics, the theory of mathematics with we call it a theory of economic and business. So now the question is find the specify the range of revenue. We need to find the range, the TR, the value of TR from what to what, subject to the maximum limit of sale, maximum limit of quantity. Sale is the maximum value of Q, maximum value of Q. Q must be not greater than 50 units. The number of Q is the maximum value. So in other words, the number of Q is less than 50. That's mean by the Q, the maximum value of Q. So in economic, okay, in order to find this, in order to find the answer, okay, we need to know the concept of Q. What is Q? Q is quantity. Based on the economic theory, quantity must be positive. Quantity cannot be negative. Never negative when we're talking about quantity. Number of product sold, number of quantities produced, Q must be positive. So indirectly, we can say that the minimum value of Q must be 0. The number of Q, when we say that the maximum value of Q is 50, so the range for quantity, the minimum value for quantity is always 0. So it's to be specific, based on the question, if the Q maximum value of Q is 50, that can also be written as we can also say that the quantity is between 0 and 50. So now this equation is referred to Q, so this is a domain, because Q is input. The set of the set value of input, the set value of Q is domain. We can say that the value of Q is between 0 and 50. Okay, so we need to find the range. What is range? Range must be the TR. We need to find the value of TR between what and what. Let's say TR between A and B. The value of TR is subject to the value of Q. We know that the minimum value of Q is 0. The maximum value of Q is 50. So we can, based on the information, we can find the range of TR. Because the value of TR between A and B. So what is A? A is a minimum value of TR. So they is subject to the minimum value of Q. So TR when Q equals 0. 100 times 0 minus 0 squared. 0 minus Q, 0 equals 0. So TR, the minimum value of TR in this case is also 0. Okay, if you refer to the theory, the value of TR must be positive, never negative. Total revenue, because P times Q. So basically the minimum value of TR is also 0, same to the quantity. So now we need to find, okay, the next one is the maximum value of TR. Subject to the maximum value of Q, 50 minus 50 squared. The answer is 2,500. 2,500. 2,500 is the maximum value of total revenue. So the range for TR we can write here. We can rewrite this equation. The TR must be between 0 and 2,500 if quantity, the maximum value of quantity is 50. That's how to find the range, how to apply the mathematics in the economic equation. So any question so far? Is everything clear?
Yes, clear, doctor.
Yeah, I hope you can understand what is domain and range. Input and output, or dependent and independent. Okay. The next one is about the difference between function and relation. Fungsi dan hubungan. Okay. There are four figures here, figure 1.1, 1.2, 1.2, and 1.4. Okay, there are two terms here, function and relation. Fungsi, function is fungsi, relation is hubungan. Fungsi dan hubungan. A relationship, hubungan is a mapping from a set of domain to set of range, when which element is in a set of domain having one or more element, one or more element. There is element, one or more element in a set of range. So when we're talking about the relationship refer to the domain and range. Refer to the domain and range. There are four types of relationship. One-to-one relationship. Each input has only one output. One-to-one. One X produce one Y. One input produce one output. Or we can also have a one-to-many relationship. At least one input has more than one output. At least one input has more than one output. At least we have one X has more than one X, one Y. That's because we get one-to-many relationship. Okay, as figure 1, if we can map this relationship one-to-one, one X, one range. X1 related to Y1, X2 related to Y2, X3 related to Y3. There is one-to-one relationship. Okay, this relationship is also called as a function. When we're talking about function, we are talking about the one-to-one relationship. One X produce one Y. One input produce one output. Other than that, there is no function. There's not function. We call it it's a relationship. For example, 1.2, one-to-many. One X, at least we have one X here, has two output. X1 can produce Y1 and Y2. X2 can produce Y3, for example. We have one input here. This input can produce two output. Okay, this relationship is not a function. We call it ini adalah hubungan saja. Dia bukan fungsi. Dia hanya hubungan. Same goes to figure 1.3. We have many to many. The relation is many to one. Okay, many to one. There is more than one input having the same output. For example, X1 and X2 has same output. X1 can produce Y1. X2 also produce Y1. We have two input can produce same output. At least one. That's relationship one. The relationship of many to one. And then the last one is a many to many. Many to many relationship. We have at least one input has more than one output. There is more than one output even the same output. For example, X1 and X2 can produce same output. And also at the same time, X2 can also produce Y1 and Y2. This relationship is we can call it as many to many relationship. In other words, if one-to-one relationship, one output produce one input, that's function. The function refers to the situation when one X can produce one Y only, one input and one output. Other than that, there is no relationship. There is no function. We just call it as a relationship. So in other words, we can say that every function is a relation, but every function is a relationship because one-to-one is also a relation, but not all relationships are function. A function is a subset of relationship. Maybe we have a relationship. It's not necessarily the relationship is a function. And that's about the difference between the relation and function. Fungsi dan hubungan. Fungsi dan hubungan. Okay. how to present the function of the relationship. How to present. How to present. Okay, there are several ways to present the relationship function. We can draw the map. We can draw the mapping. We can order a pair, or we can plot the coordinate point. For example, if you refer to the example 1.1 again, we can map the relationship. For example, let's say we have x, y. Please refer to page example 1.1. We have 2, 4, and 6, and then y, the output is 5, 11, and 70. Okay, there is a 1-to-1 relationship. 1-to-1, 1-to-1 relationship between x and y. That we call it as a also as a function. Okay, and then we can also draw plot the coordinate. Again, refer to the example 1.1. We have domain set and the range set here. Okay, there is for x. Maybe this x1, y, x1, x2, x1, x2, x3, y1, y2, y3. From this domain set. Okay, for this x2, when x equal 2, y equal 5. When x equal 4, y equal 11. When x equal 6, y equal 17. This relation can also written in the coordinate point. In the coordinate form, the first point is for x, the second point is for y. Based on this example, the coordinate point is when x equal 2, y equal 5. The coordinate is 2 and 5. When x equal 4, y equal 11. The coordinate point is 4 and 11. Yes, any question?
No question.
Okay, I heard something. I thought question was so okay. That's never mind. Okay. If x equals 6, y equals 70. So the coordinate point is 6 and 70. Okay, that is the coordinate point. We have one bracket here, open bracket and close bracket. The first number is for x. The second number is for y. This for x and domain, and it also represent domain and range. That's for the first. The second method, we just write the coordinate point. The next one, we can plot the coordinate point. We can plot that coordinate point between x and y. Again, I think based on there is standard procedure, standard form in mathematics. When we want to draw the line, we need to have an x-axis. The horizontal axis is for x-axis, and the vertical axis is y-axis. And then the intersection between x and y, there is a origin point. The origin point, titik origin, titik asalan, the origin point, the value is 0. At that point, the value of y and x equal to 0. So we can draw the scale for y and x. The first point is 2 and 5. We just plot this point just to refer when x equal to y equal 5. That's the coordinate point. The second one, when x equal 4, y equal 11. Then the last one is 6, 17, when x equal 6, y equal 17. And that's how to plot the coordinate point to show the relationship between x and y. As you can see here, when the value of x increase from x, 4, and 6, the value of y is increased. It's also increased 5, 11, and 17. In other words, we can say that it's positive relationship between x and x and y. Okay, and then the next one, we can draw a line, sketch the graph. Draw a graph, sketch the graph for this function y equal to 3x minus 1 based on this coordinate point. We just connect all the point. You just take your ruler and draw the coordinate point, and then you take now you can see we have a one line here like this one red line here. This line is for y equal to 3x minus 1. This line is a combination of the coordinate point that belong to the equation. That we call it as the sketch the graph. That's a linear. That's why in the concept we call it as a linear function. Okay. That's how to what we call it, how to show the relationship between x and y, between domain and which. First, we can draw the line, or we can find the we can we can draw a mapping between x and y, or we can draw we can write the coordinate point or plot the coordinate point, and then draw the line to show the relationship between x and y, between domain and which. Okay, just for example, 1.5. Let's say I have this question. We have domain. Let's say for this example, we have the domain is 0, 5, 10, and 20. 0, 5, 10, and 0, 5, 10, and 20. Y squared equal to x. This also can be written as y equal to y equal x and then square root of x. Y equal to square root of x. And then since we have a domain 0, 5, 10, and 20. 0, 5, 10, and 20. And then when x equals 0, y also equal 0. Okay, in this case, you need a scientific calculator. That's why I said earlier, you need scientific calculator. And then when x equal 5, the square root of 5 is equal to 2.236. The square root of 5, just for example, the square root of 5 is equal to 2.236. And then when we take the power of 2 for 2.236, we also this equal to 5. You can check with the calculator. But for this case, in mathematics, this value has two numbers, positive and negative. So this also equal to 2.236 square root. You can check with your calculator. Negative 2.236 square root is also equal to positive. When you use your calculator, because negative number times negative number equal to positive. So this domain phi has two value of range, positive and negative. When we draw the map, we can have we can have one too many. because one to many, because we have one input can produce two output. One output can produce two output, and then there is the graph for the there's a graph for the equation y squared equal to x, or x equal to y squared. The graph is unique. There is a non-linear graph. And then in this case, since each value of x, each value of output can produce each value of input can produce two output. So this equation y squared equal x is not a function. There is a relationship between y and x. Okay, that's how to identify whether this function is relationship or function. Is the equation is function or relation. Okay, I think that's about the next one is about the general form of function. Okay, the general form of function. How to write the general form. So sometimes let's say we can use a letter such as F, G, capital F or capital G, to show to label the function. Okay, for example, assume if F represent a function defined by y equal to x plus 2, then we can also write fx. Then the notation fx can be read as a f of x. Okay, this one f in bracket of x. This is a f of x. Is used to denote the output number that corresponding to the input number. When x equal some value, what is y? Y equal to we need to replace x into the y. So this equation can be written whether we can write y equal to x plus 2 or fx. We can also write as fx equal to x plus 2. The same thing. So if we write f3, what does it mean? F in bracket 3. F in bracket 3. Let's see, F in bracket. F in bracket 3. So what does it mean? Okay, we just replace 3x we just replace x. We just substitute x with 3. Yeah, 3 plus 2 equal 5. That's all. When I write f in bracket 3, that means we need to replace x equal 3 in the equation, and then 5 is the value of the function. So in terms of coordinate, the coordinate point is x equal 3, y equal 5. That's for the x and y. Okay, the next is about the we have here is dependent and independent. Okay, dependent and independent variable. Okay, again, what is dependent and dependent variable? Okay, I refer back to our example 1.1. Y equal to what is y? Okay, y equal to 3x minus 1. Y equal to 3x minus 1. Because they have a few terms, few label for y and x. As I said earlier, y is output, x is input. Y is output, x is input. The value of y is depend on the value of x. Normally, we need to identify what is x. What is x? We need to identify what is x before we can get y. So, in other words, x will determine y. The value of y is determined by x. So we can also say that y is depend on x. x x is dependent. Y is x is independent. Y is dependent. So in other words, the output is also related to the dependent. Y is also known as a dependent variable. And then the output is independent. In bahasa Melayu, dependent is bersandar, bergantung. Independent is bebas, pemberi ubah bebas, pemberi ubah tidak bersandar. Pemberi ubah tidak bersandar in bahasa Melayu. Okay, that's why sometimes in this class, I will use word dependent, independent, input, output, domain, and which. That's the basic concept of y and x. So why we can say, when we're talking about y, when we're talking about dependent, output, range, all these things is related to the y. When we're talking about input, domain, independent, that related to the x in the equation. Okay, that's the concept of input and output, range and domain, dependent and independent. Okay. Okay, the last one for today is about the example 1.7. Okay, 1.7. Okay, I would like to explain about the hollow dot. Hollow dot, the white dot, that we call it as sometimes sometimes this point, this dot is a white dot, or the second one is a black dot or black point. Black dot or black point. Okay, white and black dot is very important. That will determine the value of y, the value of the function. Okay, white dot or hollow dot show that the value of y, the value of function, the value of y is not defined at that point. Okay, I hope you can remember this concept. When the hollow dot, the white dot, refer to the situation where hollow dot say that the value of function, the value of y, the value of output, the value of dependent variable, the value of range does not exist. That is not defined at that point. Okay, black dot show that the value of function is defined, is calculated, can be measured at that point. That's why these two type of dot, white or black, is very important in order to because they have different meaning. We call it whether if you want to check whether the function, the value of y, the value of output exists or not. This we can use a black dot or black or white dot to identify that, to represent the existence of x and y. Okay, for example, let's see. I have this this question. Let's say, okay, I would like to draw this. Let's say, just for example, to show you. Let's see, I take the screenshot here. Okay. Example 1.7. Okay, good. Nice. Okay, I hope you can see uh, this graph. Please refer to example 1.7. Okay, how to draw this graph? Okay, how to draw this graph? Basically, how to read, to draw, and to read this graph. Okay, I will show you how to draw this graph. Okay, I just need this uh, this and this equation only. Okay, how to draw this structural equation? This function has three stages here, depend on the value of y. Okay, I think I need to screenshot again. Okay, let's say where's the original? Okay, this one. I, I, I just want this question. Okay, I'll determine where y equal to y equals 0 and y equals negative represent function or relation. Okay, first I will show you how to draw this graph. How to draw this graph. Okay, to draw the function, we need y-axis and x-axis. We need the horizontal line and the vertical line. Okay, the horizontal line, let's see. Okay, let's see. It is horizontal. Then the vertical line, we need to draw the vertical line. Okay. Okay. Normally we will write this as x and y. X and y. The origin point, the intersection between these two line, two axis is origin, the origin point, the titik asalan, the titik origin when x equals 0, y equals 0. Okay, now the first part is we need to just write this equation. Determine whether, okay, let's say y equal to, okay, the first part, y equal to, when y equal to, if x greater than 1, if x greater than 1, that the connection, the how to read this first, the first structure, the first part of this equation. Basically this equation has three parts. When y equal to, if x less than is x, if x greater than 1, sorry, if x greater than 1. Okay, so how to draw this? Y equal to, we just plot, let's say y equal to is here, y equal to is here, let's say that's y y equal to, I write here 2, and then we just draw a line. We just draw a horizontal line like this. I heard something. Any question? If any question, please turn off your mic. Otherwise, you will disturb the recording. Okay, let's say this now we draw the horizontal line. Is y equal to, okay, this the line, and then this line y equal to exists if x greater than 1. If x greater than that, x greater than 1. So where is x equal to 1? So let's say that x equal to 1 must be, I just plot here, x equal 1 here. X equal 1 here. Okay. Now I take ruler again. Okay. I just draw the one line here to show this area is for x equal 1. For x equal 1. It is for x equal 1. X equal 1. This line is for x equal 1. So for the y equal to, this line is y equal to, this line only exists if x greater than 1. So x greater than 1 is start from this line and go to the right of the line, and then the other part of the line I need to delete this line until the line x equal 1. Okay, this one. That's why we only have a part of the line. Okay, that's the first structure of the equation. The second one, if y equals 0, if x equal 1. If x equal 1, y equals 0. So we need to find where is x equal 1. Okay, this x equal 1. Y equals 0. Y equals 0 at this point. I can write here, when x equal 1, y equal 0. So that's why I put I draw the black dot here, because the value of y exists at that point. When x equal 1, y equal 0. Okay, the third one is y equal to -2 if x less than 1. So again, I need to label where is -2. Let's say this is a -2. So we draw the line, horizontal line, x equal to y equal to -2. Okay, let's say this line. This line exists when x less than 1. X less than 1. In other words, we need to erase the line. We need to erase the line when x greater than 1. This line only exists when x greater than less than 1. This area only. Okay, this line is y equal -2 if x less than 1. The other one is y equal 2 if x greater than 1. When x equal 1, y equal 0. Okay, that's how to draw this line basically. So now at line x equal 1, okay, we need to Okay, there is a coordinate point here. Okay, let's say there is a coordinate point. This coordinate point is for x equal 1, y equal 2. Okay, the other one is x equal 1, y equal -2. So based on this equation, when x equal 1, y equals 0. The value of y exists at point 0, not at point 2 or -2. That's why for this graph, at let's say at I put a label here a. Let's see, I put label here A, B, and C. A, B, and C. At point A and point C, we need to draw the white dot. Because at A and B, the value of y does not exist. The value of y only exists at point B. So at point B, we draw the black point. That's the difference between white dot and black dot. The black dot shows that the value of y does not exist at that point. The value of y does not exist at point A and point C. The value of y only exists at point B. That's how to draw and how to read that any point on the graph. So the next question we need to identify whether y is function or relation. Y is function or relation. Y is function. Function is a relation, but relation is not necessarily a function. The equation is function if there is only one-to-one relationship between input and output. One output can produce one output. That's function. Other than that, is a relation. So for this case, we need to know that, let's say, when at any point we need to find whether one x only produce one y. One x only whether x can produce one y or more than one y. One x, one y. The most important thing, one x, one y. So when x equal 1, y equals 0. 1x, 1, 1. For example, let's say when x equal 1, y equal 0. Let's say I have another one. When x equal 10, let's say 10, y equal 2. When x equal, let's say 15, x equal 15, y equal 2. X equal 10, y equal 2, x equal 1, y equal 0. And then when x equal, let's say negative 10 and negative 15, negative 10, negative 50, we get only 1y, negative 2. When x equal 10, y equal negative 2. When x equal 50, y equal negative 2. So we can see here the relationship is what we call it as one output can produce one output can produce one input can produce one input produce one output. uh, uh, for example, each value of x only can produce one value of y. So in this case, we can conclude that since each input only produce one output, it doesn't matter whether the output is the same or not. For example, if x equal 10 and x equal 50, we get 2. The value of y equal 2. So for x itself, when x equal 10, they only can produce one output, 2. Same to the 15. The only one output equal to 2. So in this case, we can conclude that this relationship is function. This relationship is function. This function is close to is equal to the figure 1.3. If you can see, there is many to one. Despite of 1 to 1, there are many to one in this case. But the main point here is one X can only produce one Y. It doesn't matter when whether the Y is same or not, but the issue is we must make sure that only one X can only produce one Y. So in this case, this equation can be considered as a function. That's how to identify whether the equation is a function or not. Okay, if I change this equation, just for example, if I change this equation, let's say I put like this one. I just write this one when I add this one. Y equal to if X greater than or equal 1. And then the second one, Y equals 0 if X equal 1. Y equal -2 if X less than 1. So for this case, okay, for this example only, so the first structure of the equation now is changed to the if y equal if x y equal to if x equal or greater than 1. So the value of y exists at point A. Now I need to draw at point A the black dot, black point here, because the value of y exists at this point when x equal to 1. So in other words, when x equal 1, there are two values of y equal 0 and y equal 2. When x equal 1. So this relationship, I can draw this line, this red line. Now in this case, there is one output. There is one output when x equal 1. There is one input when x equal 1. This input can produce two output. When one input can produce two output, the equation is considered as a relationship, not a function. That the difference between function and relation. We need to check whether if one input can produce one output, that is a function. But if one input can produce more than one output, can produce two output, three output, and so on, the function is called as a relationship. Okay, that's the difference between function and relationship. Okay. Any question so far? I think that's all for today. That's all for today that related to the introduction of the topic 1. Okay, the rest I hope you can read by yourself. The other part about this section from topic 1 until from page 1 until page 8. And then for next meeting, 2nd April, our discussion will start on part 2. Part 2, linear function. This part will discuss on 2 April. At Pusanika Smell, face to face. Okay, I think that's all for today. Any question?
Doctor, can you I have a question. Can you rewind just the last bit on the relation when we swap out the equation from function, the graph, yeah, to relation.
But then when I what?
When we swap up the equation, this equation, into relation, because the example was function, right? So
okay. That for example 1.7, this equation is a function. This equation is a function because there is only one-to-one this function, because one input
Equals to one
uh,
output.
can produce one output. Okay, let's say I just change this the first structure of this equation. I change to the this one. Let's say I just put this one. Okay, this x equal or greater than 1. Okay, now how to read this? Y equal 2 if x equal and greater than 1. 1, 2, when x equal 1, y equal 2. When x equal 2, y equal 2, and so on. So when we draw this part, okay, at this point, the at this point, when x equal 1, y equal 2. When x equal 1, y equal 2. The value of y exists at this point. Let's say this an. So when the value of y exists at this point, we need to draw the black dot here. The black dot show that the value of y exists at that point. When x equal 1, y equal 2. Assume that the second structure of the equation is remain the same. That is, when y equals 0, x equal 1. When y equals 0, x equal 1, this point B. So this point remain black dot here, remain black, to show that the value of y also exists at that point. And then the third structure of the equation, y equal to -2 if x less than 1, not include 1. So the line is the line and the white dot is remain the same. So based on this situation now, we can see here we have two black dot when x equal 1 at point A and point B. So at point A, show that the value of y exists. At point B, also show that the value of y exists. So how to read point A and point B? This point show that at point when x equal 1, remember x is input, x equal 1, y equal 0 and 2. There is two output produced by one input. So one input can produce, in this case, one value of x, that is x equal 1, can produce two output, can produce two value of y, 0 and 2. So in this case, this equation now become the relation, not function anymore. Okay, is it okay?
Yes, definitely clearer now. Thank you, Dr.
Okay, welcome. You're welcome. Okay, any other question? Okay, if no question, I think that's all for today. I think that's enough for today. I will continue our lecture on subtopic 1. On section 1.2, linear function, when we meet face to face at Pusanika on 2 April. Okay, for attendance, as I said earlier, your attendance will be recorded automatically by team. Okay, so please don't leave this meet until I end this meeting, because I have one button here, end meeting. When I click the end meeting, this section will be closed automatically, and then your attendance will be recorded. So that's all for today. Assalamualaikum. Happy Hari Raya. Next week we have no class. Next week is a cuti perayaan for UKM. So we will meet together. We will meet again after 2 weeks on 2nd April. Okay, that's all for today. Assalamualaikum and good afternoon. See you next 2 weeks, and Selamat Hari Raya. That's all.
Thank you, Dr. Selamat Hari Raya.
Thank you, Doktor.
Thank you, Doktor. Selamat Raya.
Okay, terima kasih. Welcome.